Okay, so today we're starting section 4.4, which is factoring polynomials, and we've done some factoring already, so we're getting a little bit higher degree polynomials like we've been working with. All right, so here is the steps for factoring that we had done when we did our little review of factoring before we actually started. Okay, so just going through these real quick. Always look for a GCF to start a factoring problem. And then if it's got two terms and they're both perfect squares with a minus between them, we call that a difference of squares. And there's a certain way we factor those. And then today we'll learn about number 3 here, sum or difference of cubes. There's two terms again, it's a binomial. They'll both be perfect cubes, and then this could be addition or subtraction. Okay, for the squares it has to be subtraction, but for the cubes it could be addition or subtraction. And there's a certain way, like I said, I'll show you how to factor those. The trinomial square was when we did the completing the square stuff. When the first and the third term were positive perfect squares, and then it passed our 1, 2, 3 test that we did. Okay, regular trinomials, we did those a lot, and then the grouping. All right, so you've seen all these. The only one that you haven't seen is number 3 here, sum or difference of cubes, and we'll talk about this today. All right, remember, always make sure you factor completely. So this is a review page. I just threw in this page to remind you of our thought process when we factor polynomials. Okay, so we did quadratics a lot, polynomials, but you can also factor polynomials that have a larger degree. Make sure you factor completely and go from there. All right, so here's our first example. Is there a GCF? Yes, there is. What is it? X. There you go. Let's focus. Let's cut the chatter. All right. So when I divide x into x cubed, what do I get? X squared. When I divide x into negative 4x squared, what do I get? Negative 4x. When I divide x into negative 5x, what do I get? Negative 5. So we took out the GCF, and then we got a trinomial. That's one of those regular trinomials. Okay? Since A is 1, and B is negative 4, and C is negative 5, it's easy when A is 1 to go ahead. The only way to get x squared then when it's a 1x squared is x times x. So all I'm worried about are factors of negative 5 that add up, give me negative 4. So what would those be, Mr. Wolf? Factors of negative 5 that add up to give me negative 4.
I have an idea. Wouldn't it be a negative 1 and... Wait.
We wanted to add to get negative 4.
Negative 5 and 1.
Right.
Sorry.
Negative 5.
Let's think it opposite.
And positive 1. Yeah, that's all right. That's good. Any questions on that? That's a pretty easy one, isn't it? It's factored completely. That's it. And usually, if you have a degree of 3, usually there's 3 factors. Okay? Degree of 4, 4 factors. And so on. All right? All right. How about this one? Is there a GCF?
Yeah. Why?
What is it?
Why?
Y to the third. Anything else?
3.
Yeah, 3 also. So 3y to the third. Okay, so what's 3y to the fifth divided by 3y to the third? Y to the second. Good. What is negative 48y to the third divided by 3y to the third?
16.
Yeah, negative 16. Good.
Negative. Sorry.
Questions so far? Again, all we did was take out a GCF. Now, what's that y squared minus 16 called?
Binomial.
It's a binomial, two terms, right? Are they both perfect squares? Yes. Is there a minus between them?
Yeah.
Yes. So that's number 2 on our list. A difference of squares, right? So I bring down my 3y cubed, and then we make 2 sets of parentheses for our difference of squares. And then all we do is take square roots. What's the square root of y squared? Y. That goes in the front of each parenthesis. What's the square root of 16? 4. That goes in the back of each parenthesis. Then what? One's addition, good, Sydney, and one's minus. Subtract. Okay, you guys remember difference of squares? That's nothing new for us, right? Questions on that example? Okay. Number 3 example, C. Is there a GCF?
B second. 5 Z to the second.
Right.
Oh, yeah. Yeah. 5 K.
All right. So what's 5z to the 4th divided by 5z to the 2nd? Z to the 2nd. Good. What's 30z to the 3rd divided by 5z to the 2nd? 6z. Good.
1 a.m.
What's 45z squared divided by 5z squared? 9. Right? Okay. So we pulled out our GCF. We have another trinomial there. Are the first and the third term of the trinomial positive perfect squares? Yeah,
Yeah.
they are. So it could be one of those special trinomials where we do our 1, 2, 3 test. How do we get the first number in our 1, 2, 3 test? Square root of the z squared, which is z. How do we get the second term? Square root of 9, which is 3. What do we do to get number 3? Not add, multiply. What's z times 3? 3z. What do we look at to see if it's one of those? If the number 3 is what relationship to the middle? If it's half, right? Is 3z half of 6z?
Yeah.
Yes. So it's one of those special trinomials, those trinomial squares. All right. So the way we can factor that, if you remember, when we were doing quadratics and completing the square, we put number 1 in the front and number 2 in the back. Which sign did we use? Did we use the B value sign or the C value sign? The B value sign. What's the B value sign? Addition, right? And then we squared it. That's how we factored one of those special trinomials. Okay? Now, if you didn't see that, you could just write z plus 3 and another z plus 3. That's the same as z plus 3 squared, right? You could still get it doing it as a regular trinomial. The factors of 9 that add up to 6 are 3 and 3, right? So that's one of those special trinomials. Okay, number 4 on our list, right? There are 3 terms, trinomial, first and third are positive perfect squares, and then our 1, 2, 3 test worked. Okay? Questions on example C? So far, every problem we've had a GCF, right? You should always check for that first. Will all of them have a GCF? No. But always look first, okay? All right. So that's Any questions on, we had a difference of squares there, we had a regular trinomial, and we had one of those perfect square trinomials. Good so far? All right, let's look at some more. All right, special factoring patterns. This is sum and difference of two cubes, okay? Here's what you do. First of all, you got to recognize that the two terms, the binomial, 64, 1, or 27 and 8, are perfect cubes. If you're not sure if something's a perfect cube, all right, if you go to math, look at number 4. What symbol is that? Go to math on your calculator and look at number 4. What symbol is that? Not square root.
Odd square root, third square root.
Well, it's called a cube root.
Alright.
Okay? So if you hit 4, and let's say we're not sure that 64 is a cube root, put it in there and it'll tell you. If you get a whole number, like we just did, 4, that tells you it's a perfect cube. Okay? So 64 is a perfect cube. Any variable to a multiple of 3 power. So anything to the 3rd power, or the 6th power, or the 9th power, the 12th power. That's a perfect cube. All right? So here in this example for the sum of two cubes, we got an x cubed, so that's a cube. Same with the difference, they got an x cubed. But if one of those was a 6 or a 9, they'd still be perfect cubes. Okay? So here's what you do. You make 2 sets of parentheses. The first set holds 2 terms, a binomial. The second set holds 3 terms, a trinomial. Okay? So make 2 sets of parentheses, but the second one make it a little further apart so you can put 3 terms in it. Okay? And what you do is you take the cube root of 64 x cubed, which is 4x, and that's the first term of the binomial. You take the cube root of 1, which is 1, that's the second term of the binomial. These signs always match. If it's addition, your binomial is addition. If it's subtraction, like this difference, then your binomial is subtraction. All right? The cube root of 27x cubed is 3x. The cube root of 8 is 2. So that's where the 4x and the 1 came from, and the 3x and the 2. Just taking cube roots. Questions on the binomial part? William, stay with us. Cube roots. All right? To get the trinomial part, okay, you take this first term and you square it to get this term. 4x squared equals 16x squared. 3x squared gives you that 9x squared. Okay? To get the middle term of the trinomial, all right, you multiply these. What's 4x times 1? 4x. What's 3x times 2? 6x. Now here's what you got to remember. When it's a addition sign in our binomial, our trinomial, they're always opposite. Opposite signs. If it's a difference of cubes like this one, then this middle term is addition. Okay? Opposite sign. Okay? And then the third term, all right? The third term is that squared. What's 1 squared? 1. And what's 8 squared? I'm sorry, not the 8. Not the original. I circled the wrong one for both. My bad. you circle the binomial, like I did here with the 4. I made a mistake. All right. You take this one and square it to get that one. And you take this 2 and square it to get that. Okay, that's how it always works. All right, so let's look at some examples of those to go through it. Once you do a couple, you get the hang of it. I don't think there's any here. We got to go to the next slide. All right, so is x cubed a perfect cube? Yeah. Is 125 a perfect cube? Well, let's check. Go to math, number 4, 125. Is that a perfect cube? Yeah. Okay. So when we factor this, then we make binomial set of parentheses and a trinomial set. What's the cube root of x cubed? X. This sign is addition, so they match up. And we just found out the cube root of 125 is what? 5. So there's our binomial part. Okay? Again, to do the trinomial part, take the first term of the binomial, x, and square it. What's x times x? Right. Okay. What did I say about this sign and the middle term sign? Opposite. So this is minus. And what did we say? How we got that? Multiply those. What's x times 5? 5x. This third term, I don't think I stressed that the first when I was going over this, is always addition. Okay? If you go back to this, this is always addition, that third term. Okay? I forgot to mention that. All right? And then I square the 5. What's 5 times 5? 25. We have it factored. We just factored that sum of cubes. That's it. Do them the same every time. Now, we didn't look for a GCF, but we should have. Was there a GCF? No. Okay, but always look for a GCF to start. Okay. So we already said 64 was a perfect cube, right? What's the cube root of 64? 4, right?
Yeah.
So we know it's x minus 4. Who can tell me what the trinomial is? X squared. Good. Say that again, Connor. X squared plus 4x plus 16. Good. Square the first term. Square the x. Since that was minus, the middle term's plus. Remember, they're opposite. Multiply the x and the 4 together to get the middle, 4x. And then square the 4. What's 4 times 4? 16. Remember, that's always plus that third one. Questions? So that was a difference of cubes because it was subtraction. A was a sum of cubes because that was addition. Okay? Remember, it's when we have squares, it has to be subtraction, right? It has to be a difference of perfect squares. If it was a sum of perfect squares, we can't factor. But for cubes, addition and subtraction are both able to be done. So, is there a GCF?
Yes.
Yeah, we got to pull that out.
S squared.
What else?
I don't know.
What number goes into 16 and 54?
2. 4.
Just 2?
4.
4?
8.
I think it's just 2, isn't it?
I don't know.
4 won't go into 54.
0.
All right, so 2 works. So what's 16s to the 5th divided by 2s to the 2nd? 8s to the 3rd. What's 54s squared divided by 2s squared?
27.
27, yeah. Okay. So, is 8s cubed and 27 perfect cubes?
Yes, it is.
Yeah.
Yeah.
All right. So, we bring down our 2s squared. That's still part of our factored form. There's our binomial, parenthesis. Here's our trinomial, parenthesis. What's the what's the cube root of 8s cubed? 2s. Is it plus or minus in my binomial?
Plus.
Plus. What's the cube root of 27?
3.
3.
3.
Right? Again, just go to your, all right, go to your math, number 4, 27, oops. And you'll see the 3 there, right? All right, Jordan, what's my first term of my trinomial? Yeah, what else? Well, you got to square both of those.
S squared plus 4s.
Well, it's just, what's 2 squared?
4.
So it's 4s squared.
Okay.
All right? All right. Caitlin, what's the middle term? Not 5s. Don't add them, multiply them. Good. Is it plus or minus? Good. Opposite of that sign, right? Colt, Guy, what's the last term?
9.
Plus or minus? Always plus, right? Questions? Everyone understand where we got all those?
Yeah.
Cube root
Quite easy.
for the 2s and the 3. Square the 2s for the 4s squared. Multiply those together for the 6s. Opposite signs. Square the 3 to get the 9. Always plus. I think there's a D. You guys try that one.
Okay. Okay. No, I know. It's so funny. I do. I do. I mean, nothing is like
Hey, not a point thing.
that's your thing. You're the guy in that video.
Yeah, I just hate the
Hey, look. Hey, look. Nah, you didn't. Hey, gotta keep me in line.
You guys played last night, right?
Yeah.
How'd you do? It's over? Hey, Ben, did you go there too?
You're okay.
So, you guys get to practice one day at all?
I'll believe you.
Sounds like it.
I haven't gotten it yet. I got 2 S there.
I guess we could have.
I believe you. I believe you.
You're gonna do your hair, and you're just gonna leave this hair on. I really want it.
I don't know. It's my hair was bad.
No. I think it looks like real good.
Oh, that's possible. Remember I did that in Milwaukee then before. I thought it was me. You're not forgiven. What are you, boys?
Come on. Why?
It's just for my bad. I take that on.
You. What's up?
How?
It's negative?
Yeah.
Wait, why? Just two not going?
Good, huh?
Caleb,
Since they're both negative, I take a negative out with your GCF.
Oh my god, I'm feeling so bad.
Alright. 8,
Right.
8, S3.
Good.
And it'd be minus 25, wouldn't it?
Plus.
Or plus 20.
Caleb.
I thought it would be like. Oh, it's half. Never mind.
I would like to give that one. And then, wait, Caleb, it was here.
Yeah. It's negative s squared and then.
No, I don't know, where do you set up the thing?
That's
Well,
right.
that's why I need a teacher.
How you make your binomial. Put your negative 2s squared out. What's the cube root of 8s cubed? 2s, yeah. 2s? That's the third. Cube root of 8 is
What? Wait, where do I get the cube?
oh, Sophia, the cube root of 8 is 2, not an s. Right?
How you get the cube root? Caleb, where's the cube root button?
Not listening.
I'm just imagining. Where's the cube root button?
I don't use this. I don't have this back in math 4. Not listening.
All right, you guys are doing a good job.
I am.
What's the GCF?
Negative 2s squared.
I believe you.
Right. Since they're both negative, I take the negative out also. Okay?
I believe you.
Now, what's negative 16 divided by negative 2?
Negative 8.
Positive 8, right?
I'm not on a roll today.
S to the 5th divided by S squared is S to the 3rd, right? Is that a perfect cube? Yeah, remember 1, 8, 27, 64, 125. Those are ones you see a lot. Plus 125. Negative 250x s squared divided by negative 2s squared is a positive 125. So that is a sum of cubes. So our binomial is the cube root of 8s cubed, which is 2s, plus cube root of 125 is 5. Okay? Take the 2s and square it. 2s times 2s is 4s squared. Since it's addition in my binomial, my middle term is minus, what's 2s times 5? 2s times 5. 10s. Always addition. And what's 5 squared? 25. So there's our factored form of that binomial we have. Okay? All right. What is it when we have 4 terms? What do we call it? Number 6 on our list.
Quadnomial.
Now, what do we call the kind of problem it is? We've done this already this year.
Dude, you can't socially give me to this somehow.
We call it grouping, right?
Yeah.
Once we group them, what do we look for? We start at the top. What's always the top? GCF. What's the GCF of the first group?
Z2.
Yeah, Z squared. What's Z cubed divided by Z squared? What's 5Z squared divided by Z squared? 5. Okay. When this third term has subtraction in front of it, like this one, we always pull that minus sign out or that negative sign.
I don't remember.
What else is common to those two terms?
A 4.
A 4.
Oh, yeah. 4.
So what's negative 4z divided by negative 4? Z. What's negative 20 divided by negative 4? Positive 5.
Just 5.
Are these the same?
Yeah.
Yes, they are.
Is that what we want to happen? Yeah.
Exactly.
Okay.
Exactly.
So, Mr. Collins, what is the two factors now?
Z squared minus 4 is
Good. The GCS is one factor, and the Z plus 5, the ones that were the same, is the other factor. Is that factored completely?
Yeah. No.
Guys.
Dude.
Get your head in the game.
Look, you can't even answer.
Berkey, settle down.
Yeah.
What do we call Z squared minus 4 again? The perfect squares. Is there a minus sign between them?
Yeah.
Yeah, so that's a difference of squares. So we got to go another step. Z plus 5 we can't do any more with. What's the square root of Z squared? Z. What's the square root of 4? 2. One's addition, one's subtraction. Remember? Now we're finished.
Oh, okay.
Now we have
Okay?
Now we have homework.
I think we got one more example to look at.
Then the homework.
GCF?
4. No, none.
None.
Hey.
Right. Are those both perfect squares?
Yeah.
Yes.
Yeah.
Is there a minus between them?
Yep.
Yes. So another difference of squares. What's the square root of the first term?
4.
X squared, right? What's the square root of the 81?
Negative 5.
Then what? Plus
Plus
or minus. Is that factored completely?
No.
No. Which one's not completed?
Both of them. No, it's not the first one.
Just the difference. Can you go any further with the sum? No. So it stays the same. When it's addition and they're perfect squares, you can't factor. But when it's subtraction, like the second one, and it's a different, both perfect squares, then I can go further. What's the square root of 4x squared? 2x.
How come minus 9 is
What's the square root of 9? 3.
plus and minus?
Plus or minus. Is that one a difference of perfect squares?
No.
So we have factored that completely. So again, you guys did well when we did the factoring before. You did well today, it seemed like. The new one, pay attention please.
I got
The new one was the sum and difference of cubes, right? All the other ones we had done before.
Yeah.
So you guys did a good job today. Make sure you practice tonight. That's what the homework's for. Okay? What's the 3 in parentheses mean? Every third one, right? 3, 6, 9, and so on. You don't have to do number 18.
You're so gracious.
It's just one they did wrong, and you're supposed to